Hi, and welcome to Trigonometry. Today on Trigonometry, we're going to look at the unit circle in trigonometry. Now, the unit circle in trigonometry ends up being incredibly important and versatile, as most of the examples that you're given in problems are going to rely on sort of these well-known angles and the values of the trigonometric functions at those angles. We use them mainly in classes to give us practice problems that we can do. It's not that these angles necessarily occur a lot in nature or anything like that. It just gives us sort of a way of dealing with them without having to constantly go to a calculator. And so as a traditional part of most trigonometry classes, you need to memorize the unit circle so that you can use these common angles, frequently in practice. And you'll continue to use these even through calculus. And so having a handy way of memorizing the unit circle can be helpful. Well, one of the things that's great about the unit circle is that the values sort of repeat as you go from quadrant to quadrant. And so if you know what's going on in the first quadrant, you actually know what's going on for every quadrant in the unit circle. So if we take a look here, let's draw a unit circle real quick. And we're going to take a look at what's going on in the first quadrant here. And it's just going to basically repeat as we go around the circle. So the primary angles that you normally use is 45-degree angle, which is pi fourths, and also 30-degree angle, which is in radians pi sixths, and the 60-degree angle, which in radians is pi thirds. You're also interested in the 90-degree angle, which is pi halves in radians, and the 0-degree angle, which is also 0 radian. And what you're going to do with the unit circle here is that if the angle here is the angle from the positive x-axis, then the point on the unit circle has coordinates cosine of theta, sine of theta. So what you're really looking for when you're writing down the coordinates of the unit circle is you're trying to write down the cosine and sine of each of those angles. Well, the values that you come across, I'm just going to write them down here and then we'll talk about sort of how to memorize them, are the following. You get 1, 0 for that position, root 3 over 2 for the cosine of pi 6, and 1/2 for the sine. You get square root of 2 over 2 and square root of 2 over 2 for both the cosine and sine of the angle pi fourths. Up here you get 1/2 and root 3 over 2 for the cosine and sine of pi thirds respectively. And then finally, once you're at the top here, you have 0 and 1 for the cosine and sine of pi halves. Kind of a cool way of memorizing this, and it's as simple as counting to 4. So let me make a couple of observations here. Notice that the 1 here is also the square root of 1. And in this numerator here, I'm also going to write that as the square root of 1. So now if you look, you actually have sort of a 3, 2, 1 in these square roots here, and they're all over 2. And then on the sine values, you count up 1, 2, 3. But there's actually even more that you can say. Down here, the 1, 0 term, well, 1 can be written as the square root of 4 over 2, because the square root of 4 is 2, and so then you get the 2 divided by 2 will give you a 1. And over here, you get the square root of 0 over 2. And then you can do the same thing up here, and you can get this coordinate, the square root of 0 over 2, and the square root of 4 over 2. And so you end up getting that the cosines count down from 4, 3, 2, 1, 0, and the sines count up 0, 1, 2, 3, 4. So if you can count to 4, you can memorize that by counting down in the x's and counting up in the y's. If you can't remember which one you're counting down and which one you're counting up, notice that the x values get smaller as I move towards this position and the y values get bigger. So the x values have to count down because they're getting smaller. So that's a kind of a handy trick in order to memorize the first quadrant of the unit circle. From there, it actually ends up just being kind of straightforward what to do, because now you get these same sort of angles in each of these quadrants. In this case here, use something called the reference angles, like what's the reference angle here? So that'll be a pi sixth angle. This one here is going to be a pi fourths angle. This one here is going to be a pi thirds angle. This one here is going to be a pi halves angle. But you want to actually measure them from here. So to get to this angle here, you're going to have to take all the way around to pi and subtract off these pieces until you get back to what you want. So this angle from the positive x-axis will be pi minus the pi thirds. And so this ends up being 2 pi thirds as an angle. This one here will be pi minus pi fourths, and so will be 3 pi fourths. This one here is pi minus pi sixths, and so that'll be 5 pi sixths. And you can kind of do the same thing with these reference angles as you go around here. This is now going to add pi sixths. This is going to add pi fourths. This is going to add pi thirds to pi, and so you can get those 7 pi sixths, 5 pi fourths, 4 pi thirds, and then 3 pi halves. And you can kind of just keep going around like this. In this case here, you're going to look at off of this, all the way around is 2 pi, so this would be 2 pi minus pi sixths, and so the angle from here around is 11 pi sixths. This one here is going to be 7 pi fourths. This one here is going to be 5 pi thirds, and that gives us all the angles. Once you have all the angles, if you look, the coordinate here on the 2 pi thirds is going to be the same as the coordinates on the pi thirds. It's just going to have a negative x value to what this one has, and the same y y value. And so you can kind of just use these same values as go around. You just give the signs that work in the quadrant. Everything in the second quadrant has a negative x value and a positive y value. So this will be negative 1/2 and root 3 over 2. And you just keep going around matching what these guys are. This guy here will be negative root 2 over 2, root 2 over 2. This one will be negative root 3 over 2, 1/2. And then down here you have negative 1 and 0. When you come down here, that's going to have the same value as this one here. It's just now both coordinates are going to be negative. So this will be negative root 3 over 2 and negative 1/2 and so on. And so you kind of just follow the patterns as you go around, getting the exact same values that you had in the first quadrant, just adjusted for the signs of the quadrant, positive and negative. And that basically gives you a way of creating the entire unit circle. But it's all based off of knowing what's going on in the first quadrant. The first quadrant can be memorized just by this 4, 3, 2, 1, 0, 0, 1, 2, 3, 4 pattern, where you're doing the square root of whatever the thing that's counting over 2. And so that's kind of a handy way of memorizing the unit circle. That's it for today. We'll see you next time on Trigonometry.